Hi, this is Mr. Rankin making another video as we review for the fast. The first concept I want to talk about is probability. Probability is likelihood of something happening or not happening. Within probability, I like to talk about sample space. If you recall, sample space is possible set of all possible outcomes. As an example, if you roll a die, sample space of that one die, which is it can land on a 1, a 2, a 3, a 4, a 5, or 6. If you flip one coin, it's sample space. It can land on heads. Sorry, it can land on heads or it can land on tails. If you flip a coin two times, you can have your sample space doubles. It can land on heads the first time and heads the second time. It can land on heads the first time and tails the second time. It can land on tails the first time and heads the second time. It can land on tails the first time and tails the second time. So when we're looking at this, well, this is a tree diagram, which is one of the systematic ways of writing or listing your sample space. If you have two coin toss, you have four possible outcomes. And so the far right row or column will show you all your possible outcomes. You also can show a sample space as a list. You can also show sample space as a table. If you don't want to write out all the different possibilities, because that might take some time, you can use what's called the fundamental counting principle. And how the fundamental counting principle works is, let's say you're at a restaurant, and that restaurant serves three different types of sandwiches, two different types of soups, and four different types of beverages. If you simply multiply all those options together, you get your sample space, which will be 24 combinations. Okay. So again, the quick way to find your sample space is doing the fundamental counting principles with multiplying all your options together. Afterwards, I want to talk about theoretical probability. Theoretical probability, as we can see here, is what is expected to happen based off of mathematics. So theoretical is what should happen. Okay. As an example, if you flip a coin, the theoretical probability of that coin landing on heads is it should land on heads. Sorry, it should land on the heads 50% of the time, or one half. It should land on tails one half of the times. So if you flip that coin 10 times, in theory, it should land on heads 5 out of 10 times, and it should land on tails again 5 out of 10 times. Now that's not always what happens in real life, and that's why we also need to talk about experimental probability. Experimental probability is found by repeating an experiment and observing the outcomes. If you see this on the test with experimental, they will give you basically what happened when they ran that experiment. So as an example here, our experimental probability is that they flip the coin 10 times and land on heads 7 times and on tails 3 times. So you just have to understand the difference between a theoretical and experimental probability. Okay. There's also compound probability. And how compound probability works is you take it, which is probability of more than one event. So as an example, if you have a die, you want to land on 1 or any other number, the chance of it landing on any one of those sides of that die or that dice is 1/6. Okay. The chance of on this spinner, which is we'll call this our second event, landing on red is 1/4. So to find the compound probability of rolling a die and then spinning the spinner, the die landing on a 1 and the spinner landing on the red is 1/4 because we're multiplying those together. And by the way, just so you know, when you see the P in the parentheses, the P in the parentheses mean parentheses, and then in the one on the inside and the red or whatever's on the inside are the events. Okay, so if I want the probability of a coin landing on tails, that's how I would write it. Okay, just so we are clear, so you understand that notation. Next, I want to move on to proportionality. If you recall, when something's proportional is being increased at the same rate, how this will look on a graph is that it will look like a straight line and it needs to go through the origin. Okay, when something is proportional, it is increased at the same rate. You cannot add anything to it. You cannot subtract anything from it. So when you see that on an equation, just be mindful of that. Also, when you're looking on a graph, if you take the y value of that graph and divide it by, excuse me, if you, let me open that back up again. If you take the y value of that graph, oh goodness. If you take the y value of that graph and divide it by the x value, you will get what is called basically your slope or your constant of proportionality. Okay, so we do 6 divided by 1. We have our constant is 6 or rate of change is 6. Okay. Moving on to the next one. Similar with a table, define if a table is proportional. You will take all your y values and divide it by your x value. So as you can see, when they do 18 divided by 2, they get 9. 36 divided by 4 is 9. 63 divided by 7 is 9. 90 divided by 10 is 9. So this is proportional, and 9 is your constant. If at any point you get a different number when you do your division, it is not proportional. Okay, so there will be no constant because it's not proportional. All right, moving on to intervals. So as you can see, there's basically three different types of intervals. This first one in the yellow, this one is decreasing. In the blue, this one is constant or staying still, or leveled. And here in the red or the maroon, that one is increasing, as you can see. The other thing to understand with intervals is that the notation that is involved. So here, if you look at the notation for, say, decreasing, as you can see, it starts decreasing at -5 and it stops decreasing at 0. So what that will look like, as you can see, if I write that over again, when it says -5, and we have the 0, you will see it has less than x and then less than your other number. So all this is saying it is happening. Basically, this is the mathematical way of saying it is happening from this number, what's on the left, to the other number. So don't let that notation intimidate you. It's not that hard. It's just saying it's going from one to the other. So as an example, when we look at the constant, it is, or let's look at increasing. It is increasing from 6 to 11. Okay, so that's why it is like 6 less than x less than 11. Okay, because this is from and to. Okay, let's move on to the next one. The last concept, if you recall, is we're going to look at a polygon. And polygon is just a closed shape with straight sides. If you recall from yesterday, every triangle is 180 degrees. Okay, and so if you go from three sides on a triangle to four sides, basically you are adding another triangle. So even though you went up one side, you now have two triangles in here. Okay. So to find all the degrees on the inside, you take your 180 divided by 2, and you get your 360. If you go up to a pentagon, which is five sides, okay, again, we add another side, and as you can see, we now have three triangles in here. So what you will do is you will take your 180 times 3, and you will see the sum of your interior angles for your pentagon. As for all the others, so the formula that we use is basically if n is your number of sides, you minus it by 2, okay? And that will tell you how many triangles are in your polygon. And then you'll multiply those triangles by 180, and you will find the sum of your interior angles of that polygon. Okay, so as an example, let's look at this hexagon here. I'm sorry, let me erase all this. This hexagon. So as you can see, this is six sides. 1, 2, 3, 4, 5, 6. And again, you can subtract 6 minus 4 and see that it has four triangles on the inside. And then 180 times 4 will give you your interior sum. So that is our review for today. Good luck on your assignment.